Well, good morning and good afternoon, and welcome to the webinar, Building Better Roads and Bridges with Soy. I'm your moderator, Chris Weigel from OmniTech International. We really appreciate you spending your lunchtime with us and hope that everyone and their families are continuing to stay healthy and that business is doing well. First of all, I'd like to thank our guest speakers for joining us today. We have a very full and very exciting agenda for our webinar. With us today are three industry experts, each with a unique perspective and product offering for soy-based products for infrastructure, including asphalt and concrete applications. We ask that if you have any questions or comments, please type them into the chat box. And if your question is specifically for one of the speakers, we ask that you include that person or company name with your question in the chat box. We will get to as many as time allows. Before I introduce our speakers, I'd like to turn it over to Bob Brenton, Commercialization for OmniTech International, who will indoctrinate us on why soy and asphalt and concrete applications. Bob?
Hey, thank you, Chris, and welcome everybody to this very interesting webinar. I'd like to talk about soy-based products. First of all, in the asphalt infrastructure improvement. One thing the soy products do is improve the rheological properties of the asphalt paving mixture. It does increase the binder stiffness and elasticity at high temperatures, which also helps improve the rutting resistance of the pavement. The soy products also lower the glass transition temperature, which then provides a better low temperature cracking resistance. And the lower temperature then, because of the rheological modification, you can compact it or mix the asphalt compositions at a lower temperature, which leads to some energy savings. All in all, because of the rheology and miscibility of the soy products, you end up using greater amounts of asphalt can be accommodated in the asphalt mixture. So just some examples of where soy is used in the asphalt industry. It's fog sealers, flux oils, rejuvenator oils. Something relatively new is the thermoplastic elastomers, striping, anti-strip agents. It's also used in emulsifiers and seal coats, solvent cutbacks, release agents, cleaners. It kind of covers a pretty wide range in the asphalt industry. So looking at the concrete side of the infrastructure market, the soy products are used in products that provide protection against moisture, and liquids like staining liquids and color damage. It does penetrate the surface and carry the pigment deep into the open pores and forming a strong bond and water seal. As strong as it is, it's sprayable and cleans up with soap and water, so it's nice to use. It does provide a release agent for wood or steel forms. The hydrophobic barrier protects against moisture and corrosive materials, and the clear film on the wet concrete surface does slow down the evaporation, allowing the concrete to have a more complete cure. It is a VOC compliant, biodegradable, non-toxic material. Products are listed for a Bio Preferred label. And like I say, it's a good product to use, low odor and good safety in using it in concrete products. So some places where it's used, protective seals, release agents, barrier coatings, cleaners. It's used in the stain, surface preparation. It's also used in concrete repair, steel removers, and curing agents. And here's some examples of companies that utilize soy products in their concrete industry products. It's a good story.
Well, thank you, Bob. We appreciate your insight and outlining the attributes and benefits of soy in both asphalt and concrete applications for our audience. Now, when we think about it, water and salt can have detrimental effects on concrete bridges and roads. That's why I am pleased to introduce our first speaker, Tess Finley of Green Sustains, Inc. Tess is focused on business development and accelerating the commercialization effort for Pore Shield concrete durability enhancer. Prior to Green Sustain, Inc., she founded a startup called Remobile, a company delivering high performance and safe chemistry-based consumer products. Tess received the 2017 Champion Award from the Green Chemistry and Commerce Council and was recognized in 2020 by the University of Toronto as one of the Women of Green Chemistry. At this time, I am pleased to turn it over to Tess as she demonstrates how Pore Shield Durability Enhancer can substantially extend the lifetime of concrete infrastructure. Tess?
Thanks so much, Chris. I'm really pleased to be able to be here to talk to you about Pore Shield and its ability to protect concrete long term. So I'm part of the Indiana Soybean Alliance with this work, which is a qualified state soybean board. The organization is statewide, serving Indiana soy farmers, through checkoff programs, membership, and policy. And we work really closely with the USB, the United Soybean Board, to meet demand, develop new uses for soy, and expand export markets. And it's the new uses that I'm talking to you about today. The Indiana Soybean Alliance is really committed to finding new uses for soy and spreading the word. And Pore Shield technology, and it is a technology, is one of these new uses. So let me tell you how we got here. It actually came through a market need, which is probably the best way to develop a technology. About 13 years ago, the Indiana DOT came to Purdue and the Indiana Soybean Alliance and said, we really have some problems with premature highway joint failure. It's costing us, we estimate, about $1 million a mile to repair these failed joints. And we need a solution that's going to be more durable and sustainable. And it is through this partnership that the soy methyl ester polystyrene patented technology emerged. So I've mentioned concrete durability enhancer, which is probably not terminology that you're really familiar with. We're asking you to think differently. It is a new category. The soy methyl ester polystyrene Pore Shield is not a penetrating sealer. It's not a coating. What it is, as we've said, is a concrete durability enhancer, and I'm going to describe to you why it's different in the next couple of slides. But with one application, whether it's in liquid form or in admixture, it protects concrete for 10 plus years. Now, in this market, you have to enter with performance. Don't even bother coming to the table if you don't have high performance, which we've demonstrated this technology does. But three other legs of this stool, which are just as equally strong, are that it's providing a safe and sustainable solution and that it's cost competitive. So how does it work? Well, let me tell you how it doesn't work first. I think we're all really familiar with coatings that go onto a surface or things that are called penetrating sealers, things like siloxanes and silanes. They do provide initial protection by going across the surface of concrete. There's a chemical reaction that occurs, so that cures, and it prevents moisture ions from penetrating concrete. But it's a short-term protection. They're often referred to as sacrificial coatings, and that is even true for engineering thermoplastics like epoxy coatings. Once that coating has either been eroded or damaged, water and salt can get into the surface. Now, how the Pore Shield soy methyl ester polystyrene works is when applied topically, it goes into the concrete, penetrating 2 to 3 inches into the, like capillary suction, into this pore network. It actually never cures. It's not a chemical reaction. It's a viscous material that adheres to the concrete pores and is protecting pre-existing damage and filling those pores to prevent from future damage. Now, one of the things that happens is, should something happen, let's say there's shifting or impact or some new crack or fissure occurs, this viscous material will go by capillary action and fill and self-heal, continuing that protection long term. Up above, you see, go back, please. So up above, you can see the an ASTM 666, which is a standard test in industry, testing for freeze-thaw damage. It's simulating about 20 to 30 years of intense freeze-thaw and de-icing that you might see on a highway or a bridge or a concrete structure. On the left is untreated concrete, and you can see it is significantly eroding. On the right is a solvent-based silane, which looks very much like that untreated concrete. And in the center are two samples that were treated with the soy methyl ester polystyrene, and they are intact and showing essentially no damage after this test. Now here's a picture using an indicator. A fluorescent dye was added to pore shield, penetrating the concrete 2 to 3 inches, and you can see how that capillary action works, and what I described is filling that pore network and protecting it. All of that greenish color is the pore shield within the concrete. Now this is an image having undergone another very standard ASTM test, which is 672. It is a rigorous test that we actually made even more rigorous than the ASTM, making more salt and freeze calcium chloride and freeze thaw damage. And on the left, you can see a micrograph across a concrete section. And up along the top, you can see where the damage to the surface is occurring. There's loose aggregate. There are significant scaling that's occurring on the surface. But even worse is when you look down below where those red arrows are, there's all kinds of cracking damage, and pieces of concrete are going to be coming loose. Often what you would see when you're coming across concrete that's crumbling and creating so much damage below the surface. Now, comparatively, on the right-hand side, the concrete paste is completely intact. There is no damage below the surface, and along the top of the surface is what you would expect to see from just normal erosion and a little bit of wearing away of the concrete surface, but the concrete is intact and going to be protected for many years to come. Now here's an example of real-time field use. We've done so much in terms of the lab. We've done so much in research and development, taking a look at all kinds of protection, which I'm not going to have time to talk about today, but we prevent things like calcium oxide chloride deterioration, which is also a real bad actor in terms of deteriorating concrete. But this was a field trial done in Indiana on the highway. The highway was 13 years old when we did the application. It had already gone through 13 years of freeze thaw, salt, and water damage. And the rod and silicone backer rods were removed, and part of it was treated with pore shield and part of it was left untreated. And you can see those black marks are actually silicone marks where the backer rod was taken out. But on the left-hand side, after 10 years, so now the highway is 23 years old, the joint looks the way it did the way the day it was treated. And the center picture is showing you the deterioration with an untreated highway where it continued to erode. It's going to need to be replaced very soon. The last picture is an example of that backer rod working its way out and starting to buckle the concrete where you'll have damage if something isn't done to it soon. So pore shield is really growing in use across the US and very, very quickly. One of the things you can see on the bottom right, the preparation is very easy. It's just a matter of blowing off loose debris. Then the material is sprayed on. Here's an example of it going on over a bridge. There's no concern about overspray because of the safety of the material. And it can go on any kind of concrete, whether it's horizontal, vertical, any density, new or old concrete. So I've mentioned a couple applications like bridge decks and highway joints, but it has broad application. There's actually a company that's incorporating this right into their mortar mix as an admixture so that the patch compound is protected with pore shield, and then after application, it can be sprayed around the edges to have additional insurance that no water or ions will get in there to destroy that patch. It's being used on precast structures. It's being used on sidewalks and driveways, patios, pool decks, going into animal barns where you have the slats that are in the floor. We treated retaining walls. This is an example of a salt building where the salt is stored for de-icing highways, and you can just imagine what kind of deterioration occurs when the salt is right in contact with that concrete wall. And by treating it with Pore Shield, we're able to protect the concrete and make it last longer. Retaining walls, garages, there really is no limit to the number of uses for the material. Equally important, maybe even more important, is that this cutting edge technology is really speeding transition to a circular economy. It's exceeding market sustainability standards. The product is 93% bio content and renewable, based very much, obviously, because it's based on soy. It is USDA certified 93%. It is also USDA mandatory federal purchasing certified, which is connected to projects that are funded by federal dollars. It is providing emissions reduction. It's a low VOC product below all national standards. Some, as we all know, of the most stringent standards are coming out of California, like South Coast Air Quality or CARB. Their threshold is 100 grams per liter. This material is 43.3 grams per liter, well below those standards. And by reducing replacement weight of concrete, you're reducing consumption of cement, which is one of the largest contributors to CO2 emissions. It is safe for the environment, safe for land, air, and water, and no concern over hazardous waste disposal. You can clean with soap and water. It's non-toxic for workers. We continue to hear from the applicators that they're really delighted that there are no fumes, no concern over burning their skin. You aren't required to wear PPE. It's a hazard-free SDS. And of course, infrastructure preservation. You're lowering replacement rates because less concrete is going into the landfill, and savings on material usage. When I was talking about those sacrificial coatings up front, you have to reapply those every 3 years. This material you don't. And again, you're saving on the material that's going in, and on the cost side, of course, you're saving on labor and material usage. So people think, okay, this is a great product for the northern states where you're experiencing so much in freeze thaw, but in actuality, it's a great product for all areas of the United States. Certainly the coastal regions, by virtue of the air from coastal regions, the salt in the air or the water that's coming up is deteriorating concrete. Unfortunately, we saw examples of some of that down in Florida recently. Areas that experience high levels of moisture that stays in concrete, even if it isn't going through freeze thaw, is deteriorating concrete over time. And of course, the freeze thaw area, so we can protect concrete long-term in all regions of the United States. Happy to answer any more questions that you may have, and please contact me if you'd like more information on Pore Shield. So thank you.
Tess, this was a fabulous presentation. I think we can all agree that this is indeed cutting edge, sustainable, and safe technology, which can truly accelerate the transition to a circular economy. Love the video too. So moving right along, I'm pleased to introduce our next speaker. So often we are driving through construction traffic, especially this time of the year, and we wonder why we cannot make roads last longer, saving us the agony of tearing up roads, recycling the asphalt, and repaving the roads. Well, this is the benefit of BioRestore's fog sealer and asphalt rejuvenator. Luke Meyer is General Manager of Bio-Based Spray Systems in Sydney, Ohio. He's an experienced product development chemist and application advancement leader with a strong research background in polymer chemistry, monomer synthesis, and scale-up to manufacturing environment. He earned an MS in chemistry focusing on polymer synthesis, plus possesses a strong agricultural background, including grain farming. Very appropriate. Listen closely as Luke details the advantages of BioRestore's technology for asphalt preservation. Luke?
Thank you, Chris. As she stated, I'm Luke Meyer. And usually when I give a talk, I try to first explain why it is we do what we do here at Bio-Based Spray Systems, and why we manufactured this product and are in this route. And usually when we start talking to pavement managers or road supervisors, there's a pretty good agreement that asphalt today is not as good as what it once was. And while that may not be the case, there's just multiple different processes that have changed, including the manufacturers are getting better at extracting a barrel crude. The recycled content has been increasing year by year. And then also with that increases wrap, sometimes it's even more difficult to obtain the proper density of what a job's called for, and poor density, as everybody knows, leads to premature failure usually. So what we like to get across right away usually is what is preventative maintenance and when is the best time to use a rejuvenating fog seal or fog sealer. As just in any other tool in the toolbox, there's an optimal timing for rejuvenators, and typically those are within the first 3 years of a pavement's life cycle. There are many processes, including cape seals or chip seals, that come along farther out in the life cycle when cracking occurs. But to really get the full benefits of a rejuvenator, the earlier in the life cycle a rejuvenator is applied, the better value we see the customer getting. So when we talk about applying rejuvenating fog seals, we like to always come back to the earlier the better, just like changing oil in your car. You want to get on it right away within before the engine starts knocking. So next slide. So BioRestore was started research and development in 2004. It utilizes a soy methyl ester as an essential ingredient. We optimized the polymer content when it was being developed to really overcome the friction issues that many rejuvenators have. Just a long known obvious that rejuvenators diminish the friction value initially, but we take it very seriously to try to get those friction values back to a safe value for the traveling public. We were tested by Bowers and Warner in Dayton, Ohio for the first 5 years through accelerated aging, and showed very good benefits of the effects of reducing the effects of oxidation and age hardening. So initially in 2004, when the product was developed, we were applied to a half mile of roadway in Darke County, Ohio. So this picture on the left is the treated section of the half mile versus the untreated section on the right. This we like to see, this was a picture after the first 7 years, a picture taken in 2010. There was testing done by Bowers and Warner, APART or Asphalt Pavement and Recycling Technologies. We've had testing throughout or with the National Center for Asphalt Technology, but a main thing in this picture was just, you can see the amount of deterioration that has not occurred in the treated section. This county engineer stated that it's hard to state on a general basis, but for this particular road, he received a 40% additional life cycle for a 13% additional cost of the treatment. This is a up close comparison of that road that was treated and untreated. And as you can see in the left picture, the amount of raveling that has occurred, which raveling is the first sign of failure of a pavement. The asphalt begins to fail and the fines start to be lost and swept off to the side of the road. BioRestore on the right-hand treated side showed a 40% less amount of deterioration. And on a micro paver ASTM testing, we rated after a 7-year comparison, a 64 PCI rating for the untreated section and a 75% PCI rating for a treated section of BioRestore after 7 years on the road. So after this testing and all the benefits that we saw, we made the product commercially available in 2010. In 2017, we became Usda Bio Preferred. We got certified, I guess. We've been brought to market by statewide contractors. We try to set up a local contractor in each state that brings the product to the states, the agencies, and the counties that want the product to be applied topically to good condition asphalt, like I stated earlier, within the first 3 to 4 years of asphalt's life cycle. So in the fall of 2018, there was a 7 or 8 product rejuvenator test at the National Center for Asphalt Technology, where they evaluated rejuvenators through it on the FAA P632 ranking criteria, along with friction testing as well. So the rheological benefits of BioRestore showed to be classified as good in this category. But we also like to point out that the friction values in 96 hours return to almost what the initial control section is. Just reiterating along the fact that we really make sure that after our product has been applied, the friction value returns back to its original characteristics. This graph just shows some DSR testing, or the rheology testing according to the FAA P632. The viscosity is shown in the untreated section of a 2016 paved road versus the one treatment in 2016. These cores taken in 2020. So a 4-year-old treated road still was showing the viscosity in rheology characteristics that what we like to see of a 30%, I think it's 25% reduction in viscosity, just showing that our product still is there within 4 years. And then after a second treatment, adjusting those properties even more back to the characteristics of what the optimal characteristics of asphalt to keep it flexible. We have done multiple treatments in Tyndall at the Tyndall Air Force Base. Not on the main runways because those are concrete, but on the overruns, aprons, and taxiways. So this is a picture, is just a unique picture of our process, our tracking ability. When we apply the product, we can track the amount of gallons put down, square yards treated, along with a GPS map of where the product was applied, just for our customers' knowledge to have. This report was generated in 2020, or in this early this year, on the drone overruns at Tyndall Air Force Base. Tennessee DOT has incorporated a construction joint stabilization program for the past, I think, about 10 years, where BioRestore has been the winning bid and been applied to about 3,000 miles of longitudinal joints in Tennessee. This region really seems to continue to put out the call for the products, and the crew applying the product has really came out and said that how they like the product, and it's how it goes down, how smooth it is, and really like the eco-friendliness of it. So a big differentiator between BioRestore and other rejuvenators are we offer the rejuvenator to state and global dealers, and through our state contractors, they have the option of applying the product themselves or selling it to an agency or county to do it themselves. So we launched this program in 2019, which COVID really kind of struck us at the wrong time, but counties and agencies, cities can purchase the equipment directly and apply it themselves, getting their cost of rejuvenation down significantly less than contractor applied products. This we see as a big benefit to counties and agencies that like to perform some of their own work. Maybe they still do their own chip seals or do their own crack fill, and this can be another tool incorporated into their toolbox of processes to do. And this just reiterates that counties and cities are available to do it themselves. We have all the kits on our website for purchase. There's some training videos that go along with that. I think that's all I have for that. If there are any questions, please feel free to get a hold of me or go to our website. And I want to again thank Chris for inviting me to do this webinar.
Luke, that's great. Congratulations to Mike, the president, and you and your entire team at BioRestore. It's really exciting to see how your company is one of the first to market with the soy-based rejuvenator. And you really have some nice long-standing relationships and proven reputation with municipalities and highway departments and even the private sector. So congratulations on that. Moving right along, I'd like to say that we pretty much all agree that asphalt terminals, contractors, highway departments, and private entities all aspire to save money while reducing their environmental footprint. That is why I'm pleased to introduce our next speaker, Dr. Eric Cochran, who is professor of chemical engineering at Iowa State University and CTO co-founder of Microlay Technologies. He has over 25 years experience in the fields of polymer chemistry and polymer physics. He directs the operations of the Iowa State University site of National Science Foundation, supported Center for Bioplastics and Biocomposites. It's an industry and university cooperative research center. Most recently, he was the 2021 recipient of the PMSE Cooperative Research Award from the American Chemical Society. Furthermore, he has 20 issued patents, authored 100 peer-reviewed publications, and 5 chapter books. At this time, we ask that you give your full attention to Dr. Cochran as he educates us on BioMag, soybean-based polymers as a cost and performance advantage additive for asphalt.
Well, thanks for the introduction, Chris. What I'd like to tell you about briefly today is a line of products that we're developing, collectively known as BioMag, which is a thermoplastic polymer that's made from high oleic soybean oil. So the work as it continues is an ongoing collaboration between Iowa State University, our startup company, Microlay Technologies, and our marketing and development partner, Color Biotics. We formed Microlay in 2020 as an Iowa LLC that exists to commercialize these family of soybean-based polymer technologies as cost and performance advantage additives for asphalt. The Iowa State component of the work has been going on for at least a decade, and over the years we've enjoyed support from a number of private companies, state agencies, checkoff funds, and federal agencies, with a special thanks to the United Soybean Board, especially over the last few years, as they've really helped us get through some tight spots as we go from lab to commercial scale. So the basic idea of the technology is we start with high oleic soybeans. Those are crushed into oil and then epoxidized, and then that epoxidized high oleic soybean oil is mixed with another epoxidized soybean oil based solvent, and then polymerized using our patented technology into this polymer rich liquid that we know as BioMag. So that's BioMag is 95% soy based, and it's about 50% polymer and 50% asphalt rejuvenator. So what do we develop BioMag to be useful for? We're primarily interested in asphalt additives as they exist both in the paving industries and even looking in adjacent markets like the roofing industry. Transportation infrastructure primarily, though, is where our focus is, and there's just a huge market opportunity there. In the United States, there are about 7 million lane miles of asphalt pavement. Now, a lane mile is approximately equal to an acre. So if it's easier to think in terms of acres versus lane miles, it's about 7 million, either way you look at it. Asphalt pavements are extremely energy intensive to produce and to maintain. So just a mile of the road that you see on the screen consumes the energy of about 1,000 barrels of oil to produce. and over $500,000. Over time, that investment is going to deteriorate. So intense temperature cycles, moisture, and sunlight are going to make those pavements brittle. And ultimately, they're going to fail and need to be replaced. And to the tune of about 420 tons of asphalt pavement that are used each year in the US. So energy-wise, that accounts for over 1 billion barrels of oil in terms of both raw materials, aggregate procurement, and construction uses. And if all of that construction was using 100% virgin materials, that amount of energy is staggering, accounting for over 5% of our domestic energy consumption. Polymer modification is an important tool to extend the life of pavements, especially in high traffic roadways. So the way that it works is you're trying to prevent your pavement from getting too soft in high temperatures. So you want to stiffen it up, but you don't want to stiffen it up at the expense of causing the pavement to be brittle. Polymers are a great solution to that. They can be melt blended into a base binder, and the elastic properties that the polymer adds to the asphalt enable it to resist that plastic deformation that leads to the rutting problem without overly stiffening the material at lower temperatures that exacerbates cracking. The issue is that polymer modification is quite expensive. The raw polymer adds a significant cost to the base binder, and moreover, the SBS polymers that are typically used are very difficult to integrate into the asphalt, and that can really only happen at dedicated asphalt terminals, which as a contractor, if you have a polymer modified paving job, you're really beholden to the slate of polymer modified asphalts that your only accessible terminal are going to be able to provide for you. So what Macrolay's line of products is aimed towards is both reducing the amount of energy and raw material that the new pavement construction requires, as well as enabling both asphalt terminals and contractors to benefit from the flexibility of a polymer modification system that doesn't require high shear. To that end, we have 2 products for hot mix asphalt. One is the elastomeric liquid that you've already seen on a previous slide, and that's already commercially available. And the second is a pelletized product that's currently undergoing scale-up. We're also interested in developing new formulations for biomag that could be used for things like pavement maintenance, or more recently, we've done a lot of work with 100% recycled pavements using a technology called cold-in-place recycling. For hot mix asphalt, biomag is just added directly to a virgin binder. And what that does is it adds both elastic character and some reactive chemistry to rejuvenate the aggregated asphaltenes that exist in both low quality asphalts like vacuum tower bottoms or recycled asphalts like recycled asphalt pavement. The end result is you're able to use lower cost feedstocks with biomag to get the same high performance polymer modified asphalt result. To demonstrate the value of this technology, we've been conducting several full-scale demonstration projects over the past couple of years. We've been in at least 8 states, and we're continuing to expand as our production capabilities for biomag also expand. We're very excited about the pelletized variant of biomag, where rather than a viscous liquid that would still be added by a terminal in a lower shear tank. This pelletized product would be usable directly by anybody with a simple holding tank, which includes many contractors. The idea here is that we use just a small amount of SBS to react with the components in Biomag to create a soft rubberized pellet that will dissolve in asphalt under gentle shear conditions and normal storage temperatures, which would produce a polymer modified pavement immediately after addition of that pelletized product. So this product would be primarily targeted towards asphalt terminals that don't have the equipment to do high shear, high temperature blending, and also larger contractors that want to be able to formulate their own polymer modified pavements without permission from a terminal. One of the newer products that we've developed, and we're actually on our way to NCAT to demonstrate this very week, is called Biomag Cold in Place. Cold in Place recycling is a very low energy manufacturing process for pavements that would be suitable for residential roads, parking lots, recreational trails, and other low traffic applications. Here, the idea is that an aged asphalt pavement at its end of life is going to be milled and stored in a recycled asphalt pavement or wrap pile at the milling plant. Those asphalt millings can be reintegrated into new hot mix asphalt applications, but even with the technologies like Biomag that enable you to increase the amount of recycled content that you use, for a hot mix asphalt application, you're still limited to no more than 50% wrap. A cold in place recycling application, what we're going to do is you actually just take those asphalt millings and then you lay them out onto the new roadway, and you add a cold in place recycling additive, and the action of that additive is going to be to temporarily soften the aged asphalt binder in those asphalt millings, which enables a standard compactor to achieve compaction of those asphalt millings without any added heat. And then over time, the cold in place additive is going to chemically react and harden so that that softening effect dissipates over time, leaving behind a pavement that can be driven on. So these images show some of the cold in place process in action. So over here on the left, there is a test strip that just has a very coarse gravel underlayment. You see one of our collaborators bringing in the asphalt millings on a skid steer. Those are raked out, and then in the second picture, you see the cold in place additive on the back of the truck with a simple spray nozzle array that's distributing the Biomag based cold in place additive onto those millings. And then simple compaction is occurring in the third image. And so you just drive over it a few times until you have a firm surface. And then the final finished pavement is on the right. And over a course of about a week, that pavement continues to harden and react until you get to a traffic bearing final product. So thanks for listening. And so that's just kind of a quick summary of some of the various things that we've been up to with Biomag, which is powered by that high oleic soybean oil technology.
Thank you, Eric. This truly is cutting edge technology. You know, congratulations to Chris Williams and yourself and your whole team, not only on the development, but commercializing this Biomag product line. I think it just is a testament to your industry experience. You add such tremendous value to the Industry University Cooperative Research Team, and it really helps transform this technology into commercial reality. So again, congratulations.
Thank
But
you.
this time, We have completed all 3 speaker presentations for today and hope you found these presentations very helpful to you. We will be presenting a few questions to the panel for discussion. And we ask at this time if any of the attendees have any specific questions to type them into the chat box. And if your question pertains specifically to one of the speakers, please note that with your questions. So the first question is, when did your organization start exploring soy for infrastructure applications? And what really inspired your university or company to do so? Luke, would you like to start us off?
Yeah, I stated, I guess, in our thing, we developed or started developing the product in 2004, and Mike Freistella, the president of the company, he'd been in the paving industry since the 70s, and he had been around other preservation techniques and just knew that there was a growing environmental impact, and he knew that the green, I guess, wave was coming, and that there needed to be, he just saw that the quality of asphalt over time kept deteriorating, and that preservation products and preventative treatments were the way to go. So about 2004 is when he broke off from the paving industry and company and developed this bio-based spray systems where we focus on the rejuvenator.
Oh, great. Eric, you go back a long way in this development. Tell us, why soy?
We started with soy because we just had an academic curiosity of why everything developed from soy in the polymers world was a thermoset. And getting into it, we've discovered a way to make thermoplastics out of soy. And having been the first researchers to do so, we were very eager to find things that would be useful for. And we've just found the list of useful applications just continues. And what I always tell folks about why soy is an interesting molecule to work with. It's just got so many different functional handles, a lot of different things that you can play with and manipulate. So you can really push properties to where you'd like them to be for just about any end use application.
That's true. Tess?
So why soy? Well, we are the Indiana Soybean Alliance, so that's a natural question, but I agree with what Eric said. I mean, it's really soy oil, or is this going into soy biodiesel and then is esterified into a soy methyl ester? There are so many things that you can do with that as a building block. It's not unlike the versatility of petrochemical building blocks, but because soy is so powerful, sustainable, and renewable and readily available, it has all kinds of opportunities. And in terms of why into this area, we started in 2008, obviously from a need from the Indiana Department of Transportation in collaboration with Purdue University, and we are now being used across the country and continue to grow in that area in many of the states.
Yeah, congratulations. The next question is, what do you feel is the biggest barrier to market acceptance and widespread commercialization of your soy-based products? Eric, would you like to start with that one? I know that's been a long road for you, no pun intended.
Yeah, I love the transportation industry because it's an endless source of cliches and little puns with rubber meets the road, etc. I think for us, some of the largest barriers initially we're just figuring out how do you take a new polymer to market without requiring hundreds of millions of dollars in new capital infrastructure to do that. So the final form factor of Biomag really came about as a solution to a problem that if we were going to be doing solvent-based processing to make a new polymer, then the process of extracting and isolating that polymer from the solvent was going to be a huge capital expense and also a lot of new process development. So we were really motivated to find a one pot, no cleanup kind of process, which is what led us to the product that we now call Biomag, where we're able to find an end use for the solvent and use 100% of the reactor product. So that was one of our first big barriers. Currently, what what we deal with, especially when wanting to use high wrap in new pavements, is the way that a lot of states certify binder is going to be based solely on the virgin binder properties versus the properties of the finished pavement. And new certification paradigms such as balanced mix design have been very helpful to us in that regard. And so as more agencies adopt balanced mix design principles, which actually test the properties of the pavement as placed versus the virgin binder, those types of changes are very helpful with new technologies like ours that are trying to make more use of recycled content.
Yeah, that's true. Luke or Tess, would you like to chime in on this one?
Oh, well, I agree with Eric. I think the big thing we run into is that if there's not a specification or an actual end use when it gets paved, if they're just taking specifications from the initial before, after it's been through the processing plant, out to the road, and maybe not receiving its correct compaction, until there's something in the line of performance. We haven't saw many agencies want to fully grasp rejuvenation and I guess put their arms around it.
Another thing that I would add is soy technologies continue to evolve. I know it's been around for a while, but early on, some of the early soy technologies didn't work very well. And there's a certain amount of overcoming some of that history. The newer technologies are really high performance. The technologies that you're hearing about today are providing real infrastructure improvement, and undoing some of that history is a challenge. The other piece is that we have a new category. We're concrete durability enhancers. And as Luke mentioned, the specs are written about existing technologies and existing treatments. So helping to educate the industry and build these products into a new spec, which is starting to happen as the benefits of this type of technology are being recognized. But that certainly is a hurdle.
That's true. Next question is, what advice would you like to provide our audience based on the lessons you've learned throughout the years that would help them accelerate their use of these soy-based products and infrastructure? Would anyone like to start us off on that one?
Sure, I'll reverse the order here. Lead with performance. Have to lead with performance. Obviously, it's really important to have the sustainable solution, and then eventually cost competitive will come if it isn't there already. But performance is key. And so that is, it's nice to be green, but green comes as an added benefit and real positive attribute once you have the performance in place.
Anyone else want to chime in on this one? Otherwise, we'll go to the next question.
I would just throw in that the soy community is pretty tight knit and pretty helpful. So if you're looking to get started in soy, reach out to that community, because there's a lot of questions that you can get answered really easily just by asking somebody else that's done similar things.
Yeah, that is true. I'm going to go with one more question, then we'll go to the questions that come from the audience. In formulating new products, how strong is the sustainability factor in selecting your ingredients for both asphalt and concrete applications? Is it number one, number two, or did you pretty much wrap it up with the last question?
I guess I would say sustainability is always key, but as Tess said, performance is just because it's sustainable, it has to have performance. And also, all three of them, cost competitive falls into line too. If it just because it's green does not mean it has to cost more. And that's what we need to focus on. Not everything that is green has to cost more. It can be the same price or even cheaper.
Mm-hmm. That's a good point.
But certainly keeping your environmental footprint as pristine as you can, And new carbon versus low carbon and your contribution to the circular economy life cycle of the product is critical. So those are always taken into account when creating these new products.
Mhm. That is a good point. Okay, well, let's go with the questions that are coming from the audience. First of all, very good presentation, Eric. Can you tell me the reason why high oleic soybean oil was used instead of conventional soybean oil? Does it have anything to do with the oxidation technique that was used for the high oleic as opposed to the emphasis on linoleic or linoleic content?
Yeah, that's an excellent question. So it really comes down to what we're looking for in asphalt is to maximize elasticity. And high oleic soybean oil with its reduced functionality compared to commodity soybean oil is going to make a more linear chain architecture that has more elasticity as part of it naturally. So we get a pretty significant elasticity bump if we compare a polymer made from a commodity soy versus a high oleic soy. So that's why the extra cost and limited availability justifies moving to that line for that purpose.
Good answer. The next question comes from Steve Block. What impact does the varying price of soybean oil that we have this year have on the affordability of your products? Would anyone like to take a stab at that question?
Sure, I'll take a stab at it. This is a strange year with a varying price of everything due to transportation constraints, import constraints, raw material constraints. Obviously, varying prices affect anybody at any point. With our particular product, the cost per square foot for application is so very low and so competitive that it's not a negative towards incorporating it into use by DOTs and infrastructure owners. But obviously, raw material prices are always important.
That's a good point. The next question is, how is soy methyl ester PS made? Is it a blend or a copolymer? I think this is for you, Eric.
So it is a formulation, but it is patented. We have 3 patents on this based on the studies of how to incorporate it and how to have it perform.
Bob, did you want to chime in? Do you see any other questions that I'm not scrolling down to see? Would you like to add anything in here, Bob?
Let's see, there was a question that came up on the cold in place application using biomag. Did that include the use of asphalt emulsion or not?
We have a few different prototypes. Some of them use biomag added into an asphalt emulsion, and others are purely biomag based, which is also a water-based emulsion.
Okay.
The next question says, for the group, excellent presentations. Do any of you see any carbon sequestration opportunities for further added value or even monetize from your products? Does anyone want to take that question? Otherwise, we can think about it and get back.
I think if you think about carbon sequestration in terms of preventing new carbon from being released, I guess when you're using like recycled content, you're doing that. But in terms of like direct carbon capture, haven't really thought much along those lines, but be interested in talking with you, Jimmy, if you've got ideas.
Okay. Well, I have to apologize, but that's all the time we have for questions at this time. I'd like to thank everybody for your time today and sharing your lunch hour with us. We appreciate the time you spent, and on behalf of United Soybean Board, Smith Buckland and Omnitech International. Please let us know if you have any questions, or we urge you to reach out to us if you're interested in developing products with soy or learning more about USD funding. We can assist you on the technical and commercial development of soy-based products. We'd also like to announce that next month we'll have another webinar on September 24th, this one on novel technologies for sustainable soy-based surfactants. So at this time, we enjoyed seeing you again. We hope to see you at the end of next month. We hope that you and your families and coworkers continue to stay safe and healthy. Thank you.
Thank you, Chris.